So welcome back. In today's lecture, we're analyzing under which circumstances firms can successfully coordinate their behavior. And as we've just seen, if games are played repeatedly, this may help firms to cooperate. Another way by which behavior can be coordinated one way or another is commitment. So therefore, in this video, we'll look at aggressive commitment, and in the next video, we'll move on to cooperative commitment. But for now, let's get started. So what is the intuition of aggressive commitment? The intuition is that in most situations, the players of a game have lots of options, and they like to have lots of options. So there's a strong element that as a strategic player in a game, as a participant in the market, you want to have as many options open as possible. Aggressive commitment goes in exactly the other direction. Aggressive commitment tries to eliminate those moves which would lead to unattractive equilibria. Okay, so you're limiting your option, doing an aggressive commitment, rather than expanding your options. This very often means, in game theoretic terms, that you're trying to change a game from a simultaneous game to a sequential one. As we'll see, using an example of the global airframe market. So, as you know, the global aircraft market was for a long time basically dominated by the largest plane in the world, which was the Boeing 747. Now, there's basically two firms in the world that could build a plane that's about as big or even bigger, and that's Airbus and that's Boeing. And so a while ago, there was some thinking that maybe there is room in the market for a larger plane than the 747. And so therefore, both Boeing and Airbus wanted to start thinking about a new large-scale passenger airplane. So Airbus termed this the A380. Boeing called it the 747X as an extra large. There was, however, even though the general agreement was that yes, there is a market for a larger plane, there was also an agreement that said, well, you know, there's probably not enough market. The market is not large enough for these super large planes to have two different models. So it would be either the A380 or the 747X that would be profitable in the market, or if both entered, then both would start making losses. So how do we take all that information and put it into a matrix? Well, we've got, again, as always, we've got the two players, Airbus and Boeing, and they can choose whether to stay out of this large-scale market or to enter that large-scale market. Now, if both stay where they are, then Airbus is assumed to make $2 billion in profits, $2 billion, and Boeing is assumed to make $3 billion in profits. If Airbus continues to stay out, but Boeing launches the 747X, then they take some market share of the largest plane by Airbus, and they open up the entire market for super large airplanes. So they would make $4 billion, and Airbus's profits would drop to $1 billion. If it's the other way around, so that the A380 comes into the market and Boeing stays out, then Airbus's profits would go up to $4 billion, and Boeing would lose $1 billion because they lose market share for the 747. And the issue, of course, is that if both planes get launched, then both firms would start making losses, here to the tune of $2 billion. Now, looking at this issue, looking at this situation, what are the Nash Equilibria in this game? Well, let's assume that Boeing doesn't launch the 747. What does Airbus do? They choose between not launching and launching. Not launching in this case would give them $2 billion. Launching in that case would give them $4 billion. So they're going to choose to launch the A380. If Boeing launches the 747X, then Airbus faces the choice between staying out and making $1 billion, losing some market share, or going in but losing $2 billion because the market does not sustain two planes of this size. So therefore, they're better off getting the $1 billion that comes from not launching the new product. So much for Airbus. What about Boeing? If Airbus chooses to stay out of the market, then Boeing can choose, if they stay out, they make $3 billion. If they go in, they make $4 billion. So they would choose to go in. If Airbus has launched the A380 or has committed to launch the A380, then Boeing can choose to stay out, getting 2 billion and going in and creating losses for the entire market. So therefore, their best option is again to not enter with a super large plane. So here, just looking at that, you see that we've got two Nash Equilibria. One where the A380 is launched and not the 747X, and one where the 747X is launched and not the A380. So looking at this, it's pretty clear that Airbus has a clear preference over these two Nash Equilibria, right? So Airbus wants to launch the A380, but wants to make sure that Boeing does not get to launch the 747X. Now, as we've seen in previous sessions, we've seen that if we have multiple Nash Equilibria, it's not easy always to select which one of those is going to be the one that we play. So let's see what Airbus did, or what Airbus was trying to do in trying to change the game and influence the game such that their preferred equilibrium is chosen. So they chose an aggressive commitment. They chose to move first. And they chose to move first such that even before the plane was completely developed and so on, they started building production facilities in their two hubs, Hamburg and Toulouse. And what's more is they made sure that these production facilities can only be used for the production of the A380. Okay? There's no way back. They couldn't produce a smaller plane with these production facilities. And this changed the game decisively, because this meant that Airbus was now committed to building the A380. So again, let's go back to the theory and see how that works. Well, Airbus has a choice, and they have the choice first. They have the choice of launching the A380 or not launching it. Boeing can react to that, and they can choose to launch or not launch the 747X, depending on whether Airbus has launched the A380 or not. So looking at the payoffs, we know those from the previous game matrix. If both planes are launched, losses are going to be 2 billion for each. If only the A380 is launched, then Airbus is going to make their highest profit, which is 4 billion, and Boeing is going to make 2. If only the 747X is launched, then Boeing is going to make their highest profit by making 4 billion, and Airbus is going to make 1 billion. And if none of the planes is launched, then they make profits of 2 billion for Airbus and 3 billion for Boeing. So let's try and solve this game. And let's try and find the Nash Equilibrium. So if Airbus has entered the market, Boeing could choose to launch their 747X as well, or to stay out. Given that you make minus 2 billion here and you make positive 2 billion here, this is going to be their preferred option. So if Airbus launches, then Boeing is going to stay out. On the other hand, if Airbus stays out, then Boeing can choose to enter and make 4 and stay out and make 3. So of course, their best strategy here is to enter. So now we can compare the situation from Airbus's point of view. So if Airbus enters with the A380, they're going to make 4 billion. If they're not going to enter, then Boeing is going to enter and Airbus is going to make 1 billion. So the outcome of this game, the subgame perfect Nash Equilibrium, is going to be that Airbus chooses the A380 and Boeing stays out of the market. In this short video, we've looked at aggressive commitment, and we've looked at a commitment that basically changed the game from a simultaneous game to a game where Airbus had the first move. And we could also see that this changed the dynamics of the game. It changed the outcome of the game significantly, because it meant that Airbus was able to select which of the two Nash Equilibria that we saw in the simultaneous game they were going to select. So they influenced the outcome of the game by moving first. So for now, to make sure that you grasp the concept of aggressive commitment, let's do the in-video quiz, and then we'll move on to the next video, which is going to be on cooperative commitment. So see you in a few minutes.